Jay Leno. Yes, the same Jay Leno you know from The Tonight Show. With the chin, the denim, and the encyclopedic knowledge of cars, has become an unlikely hero in the world of 3D printing. Along with his chief engineer Jim Hall, Leno has turned advanced additive manufacturing into a lifeline for saving some of the rarest vehicles on Earth. Cars that the average collector would write off as impossible to fix, because their parts literally don't exist anymore, are rolling again, thanks to this technological miracle. This isn't just about celebrity car obsession. This is a story about how technology meant for aerospace, medicine, and even space travel is being repurposed to resurrect history, one car part at a time. The Garage of Legends. Jay Leno's garage isn't really a garage. It's a museum, a laboratory, and in some ways, a time machine, housing over 180 cars and 160 motorcycles. His collection is considered one of the most diverse and valuable in the world. Step inside, and you're not just looking at machines, you're stepping into the entire history of human transportation. Each vehicle whispers a story, not just of horsepower and design, but of eras, cultures, and the relentless pursuit of innovation. Inside, you'll find everything from a 1909 Stanley steamer, a relic of the age when boiling water powered progress, to a McLaren P1 hypercar, a machine so advanced it feels like it drove in from the future. In between sit early Duesenbergs that defined American luxury, bizarre jet-powered prototypes that never quite caught on, and motorcycles that once thundered across dirt tracks and highways. Some of these vehicles are so rare that you could travel the globe and never find another. In some cases, Jay owns the only surviving example, the last living representative of its lineage. But with great rarity comes great responsibility. These aren't just cars to be admired behind velvet ropes, they are machines meant to run, to move, to breathe fire and fuel. Yet old cars break, old parts crack, corrode, or simply vanish from history. In the past, even a single broken gear or rusted valve could condemn a vehicle to permanent retirement. Its story silenced forever. But for Jay, giving up isn't an option. To him, every car is alive, and every breakdown is simply a puzzle waiting to be solved. Enter Jim Hall, the engineer behind the curtain. While Jay Leno is the face of the operation, the real wizard behind the curtain is his chief engineer, Jim Hall. If Jay is the showman, Hall is the alchemist, the man who takes impossible requests and turns them into working reality. He isn't just a mechanic, he's a machinist, designer, problem solver, and inventor rolled into one. Where most mechanics would shrug and say, "Can't be done," Hal sees an opportunity to prove that impossible is just another word for not yet. When Leno says, "We need a carburetor for a 1930s Bugatti, but no one has made one in 70 years," Hall doesn't flinch. There's no hesitation, no panic. Instead, he rolls up his sleeves, fires up the scanners, and begins the meticulous process of reverse engineering history. He treats every broken part like an archaeological artifact, something fragile, precious, and worth reviving. Hall's workspace looks more like a high-tech laboratory than a traditional garage. Laser scanners capture every microscopic detail of a part. CAD software reconstructs it in 3 dimensions, correcting imperfections and refining tolerances. From there, digital blueprints are fed into a 3D printer, capable of producing prototypes in metal or plastic. What once took months of hunting through scrapyards and antique catalogs now happens in hours. Together, Leno and Hall built a seamless workflow. Scan the broken or missing component, design or refine it in CAD, and then feed it into a printer. Within days, they're holding a piece of history, something the world thought was gone forever, restored to life and ready to roar again. How 3D printing saves the unsavable. Traditional restoration has always been a mix of detective work and blacksmithing. The first option is to hunt for new old stock parts, vintage components that have been sitting on dusty shelves for decades. forgotten until someone digs them out. The second option is to fabricate parts from scratch in a machine shop, often requiring rare tools and months of skilled labor. Both paths are costly, time-consuming, and in many cases, flat-out impossible. When you're dealing with obscure cars built in tiny production runs, sometimes the part you need simply doesn't exist anymore. This is where 3D printing changes the game entirely. Instead of waiting years to track down a single water pump housing or spending a fortune commissioning a machinist, Jay Leno's team can create what they need in days, using high-strength plastics, resins, and even advanced metal powders. They're able to manufacture parts with microscopic accuracy, down to fractions of a millimeter. Need a water pump housing for a 1916 Owen Magnetic? A car so rare that most people have never heard of it? Print it. Need a one-off custom tool to disassemble a 1930s Bentley engine? Print that too. But the true magic isn't just replication, it's reinvention. Original parts from the early 20th century were often crude by today's standards. They broke, warped, or failed under stress. With CAD software, Jim Hall can reimagine these components, strengthening weak points, shaving off unnecessary weight, or choosing materials better suited to modern performance. The result is something remarkable. A 1920s bracket that looks identical to the original, yet is stronger, lighter, and more heat-resistant. It's not just history preserved, it's history upgraded. Key takeaway number 1: preservation through innovation. Here's the first big lesson. 3D printing doesn't just copy the past, it preserves it. On the surface, it may look like a clever way to replace a broken part, but the reality runs much deeper. Each scan, each CAD file, each printed component is a safeguard against the slow erosion of history. Instead of relying on fragile, one-of-a-kind artifacts that can crumble with age, Jay and Jim are creating digital lifelines, blueprints that can outlast both the cars themselves and the people who care for them. Think about it this way. A water pump housing from a 1916 Owen Magnetic isn't just a car part. It's a piece of industrial design from an era when electricity and gasoline were battling for dominance. A fragile carburetor from a 1930s Bugatti isn't just a mechanism for mixing fuel. It's a window into the engineering mindset of pre-war Europe. By digitizing these parts, Jay and Jim are archiving far more than shapes and dimensions. They're archiving ideas, philosophies, and the cultural DNA of entire eras of innovation. This is where 3D printing becomes more than hobby tinkering. It transforms into a form of cultural conservation. Even if a car never roars to life again, its essence has been captured, cataloged, and stored for future generations. Imagine historians 100 years from now, able to study and recreate long-lost vehicles, not from grainy photos, but from exact, working digital blueprints. Every scan is a backup of history. Every print is a promise that these rare machines won't disappear into the void of time. The steam car revival. If there's one corner of Jay Leno's garage that feels like stepping into another dimension, it's his collection of steam-powered cars. The Stanley Steamer, the White Steam Car, and other relics of the early 1900s sit gleaming like artifacts from a parallel timeline. One where steam, not gasoline, won the great automotive race. To Jay, these machines aren't curiosities, they're marvels of ingenuity. Reminders of an era when inventors experimented fearlessly with what cars could be. The challenge, of course, is that keeping these machines alive is closer to sorcery than standard mechanics. Parts like boilers, valves, and fittings are not only rare, they're incredibly dangerous if made poorly. A single flawed weld or misaligned valve could mean catastrophic failure. For decades, this risk meant that many steam cars were condemned to static display, beautiful but mute. This is where Jim Hall and 3D printing came to the rescue. By scanning and digitizing fragile original parts, Hall can recreate them with aerospace-grade materials, ensuring both precision and safety. A valve that once corroded after a few years of use can now be printed stronger, tighter, and far more durable, while still preserving the exact look and feel of the original design. Leno himself admits that without 3D printing, many of his beloved steamers would sit silent, gathering dust in the garage. With it, however, they live again, not roaring like modern engines, but hissing, whistling, and steaming their way back into motion. These aren't just restorations, they're resurrections. And thanks to modern technology, the age of steam breathes once more. Key takeaway number 2. Old problems, new materials. Here's another insight worth holding on to. Old cars don't always need old solutions. Purists sometimes argue that a restoration isn't authentic unless every part is period correct, made with the same metals, plastics, and methods as the originals. But in reality, the materials of the early 20th century had serious limitations. Brass corroded, early steel warped, and plastics like bakelite crumbled to dust. Cars that once represented cutting-edge engineering often failed not because of bad ideas, but because of the material science of their time. Jay Leno's team takes a different approach. With 3D printing and advanced manufacturing, they can produce parts that not only match the originals in form, but outperform them in function. A radiator cap from 1910, once made of brass that tarnished and cracked, can now be reprinted in stainless steel, retaining its vintage look but lasting far longer. A fragile bake-like dashboard knob, notorious for shattering if you so much as looked at it wrong, can be recreated in modern resin. To the eye, it's identical. To the hand, it's sturdier, smoother, and ready to endure decades of use. This balance between authenticity and improvement is what makes the work so powerful. The cars retain their historic soul, but they also benefit from a century of scientific progress. A bracket from 1925 no longer needs to be a weak link. A valve from 1908 doesn't have to risk catastrophic failure. Instead of being slaves to the shortcomings of the past, Leno and Hall give these machines the durability they always deserved. The result? History that looks authentic, but performs better than ever. When the printer outpaces the machine shop. Here's where things start to feel revolutionary. For most of automotive history, restoring rare cars meant long waits, high costs, and plenty of frustration. If a crucial part failed, say a gear, a pump, or a housing, there were only 2 options: hunt down a replacement from the far corners of the world, or commission a machine shop to recreate it. Both options came with a heavy price. Even a relatively simple piece could take weeks or months to fabricate, often costing thousands of dollars in labor and material. Meanwhile, the car sat idle, collecting dust and begging to be driven. 3D printing completely rewrites that script. What once took months can now take mere days or even hours. A broken component is scanned, modeled, and sent to the printer. By the next morning, a new part can be in Jim Hall's hands, ready for testing and installation. The efficiency is staggering. For Leno's garage, this speed isn't a luxury, it's liberation. It means cars don't languish in storage, half disassembled and waiting for a machinist's schedule to open up. Instead, they get back on the road where they belong, rolling through California streets or appearing at car shows, living history in motion. And for the broader world of restoration, the implications are profound. The economics of preservation are shifting forever. A technology once reserved for prototyping aerospace components is now accessible to collectors, museums, and hobbyists. Cars once written off as impossible to fix suddenly have a future again. With 3D printing, time is no longer the enemy of preservation, it's an ally. Key takeaway number 3. Access for everyone. The third big lesson? This technology isn't just for celebrities with cavernous garages and television crews. Jay Leno might have the spotlight, but the tools he and Jim Hall are using are rapidly becoming available to anyone with curiosity, patience, and a bit of imagination. What once seemed like science fiction is now sitting on workbenches across the world. 3D printers, once massive and prohibitively expensive, are shrinking in size and price every year. What cost tens of thousands of dollars a decade ago can now be found for a fraction of the price, small enough to sit on a desk in a home workshop. The result is a quiet revolution. A restorer in a small-town garage, miles away from the nearest specialty shop, can scan and print parts that would have been impossible to find in the past. Instead of waiting months for an obscure shipment from overseas or paying exorbitant fees for a machinist, he can have what he needs by the end of the week. And this accessibility doesn't stop at collectors. Museums tasked with preserving artifacts, universities teaching the next generation of engineers, even hobbyists restoring motorcycles or farm equipment, all stand to benefit from the same methods Jay's team uses daily. What feels groundbreaking in Leno's garage today could become standard practice everywhere tomorrow. That's the true beauty of it. Innovation isn't locked behind velvet ropes or millionaire budgets. The same tools that keep a century-old Duesenberg alive can be used to resurrect a family heirloom or restore a forgotten project in a backyard shed. Preservation, once exclusive, is rapidly becoming accessible. Beyond cars, a model for preservation everywhere. The implications stretch far beyond automobiles. What Jay Leno and Jim Hall are doing in a California garage isn't just about keeping rare cars alive. It's about rewriting the way we think about preservation itself. The same techniques that restore a Stanley steamer or a Bugatti carburetor are being adopted in fields as diverse as aviation, medicine, and museum conservation. Consider the world's great institutions. Museums tasked with preserving antique machinery often face the same challenges as car restorers. Fragile parts, lost manufacturing methods, and the danger of using irreplaceable originals. With 3D scanning and printing, curators can replicate delicate components for display, or even fabricate functional versions for working demonstrations without ever risking the original artifact. Aerospace organizations are doing the same. Engineers have used additive manufacturing to recreate components for historic planes and rockets. Hardware too rare or complex to reproduce with traditional machining. A cracked valve from a Cold War jet engine or a fitting from the Apollo program can be scanned, improved, and rebuilt with aerospace-grade precision. These machines, like Leno's cars, don't just sit in silence, they breathe again. Medical institutions are joining in too. Early surgical tools and devices, once too fragile to handle, can now be replicated for study or display. Students can hold accurate replicas of 19th century medical instruments, while the originals remain safely preserved. Leno's garage, in this sense, is more than a private collection. It's a proving ground, a model for how technology can keep history alive, not locked away behind glass, but in motion, on the road, in the air, and even in classrooms and museums worldwide. Why this matters? So why does this story matter? Why spend so much energy, technology, and passion keeping old cars alive? The answer is simple, because cars are more than machines. They are rolling artifacts, time capsules of engineering, culture, and human ambition. Every curve of metal, every gear and piston tells us something about the era that created it. A 1901 electric car whispers of early dreams for clean energy long before Teslas filled the highways. A steam-powered engine reminds us of the fearless experimentation that came before gasoline won the throne. A Duesenberg, with its elegance and extravagance, speaks of jazz-age glamour, when access was worn like a badge of honor. Without 3D printing, many of these voices would be silenced. Fragile parts would fail, and entire machines would be condemned to sit silently in collections, frozen in time. But with it, they breathe again. They move, they roar, or hiss, in the case of steamers. And they remind us that history isn't just meant to be observed, it's meant to be experienced. Jay Leno and Jim Hall are proving something larger than car culture. Preserving the past doesn't mean rejecting the future. In fact, the future might be the only way to save the past. 3D scanning and printing aren't gimmicks or shortcuts. They're bridges, connecting centuries-old craftsmanship with cutting-edge technology. Each part printed, each engine revived, ensures that history stays in motion. Not behind glass, not locked away, but alive, functional, and inspiring. And that's why this matters. Because every time a restored car takes to the road, it isn't just transportation, it's living history, reminding us where we've been and pointing us toward where we might go. From Hollywood studios to his cavernous garage, Jay Leno has worn many hats: comedian, host, collector. But perhaps his most surprising role is pioneer of technological preservation. With Jim Hall and the power of 3D printing, Leno isn't just fixing cars. He's ensuring that the rarest vehicles on the planet continue to live, drive, and inspire. So what do you think? Should 3D printing become the standard tool for restoring history, or does it risk changing authenticity? Drop your thoughts in the comments. We'd love to hear your take. And if you enjoyed this deep dive, don't forget to like, subscribe, and share. Because sometimes the future of history is built layer by layer. Stay blessed and stay curious.